In this image, we have the SR04 pinout, and you'll notice that there are 4 pins, VCC and ground, and the trigger, which is going to be connected to an Arduino output, and echo to an Arduino input. Okay, the VCC supplies the power to the device, and you should connect that to the regulated output, not to the VCC or the 5-volt supply on the Arduino. Welcome. This is an example of the ultrasound sensor software for the Arduino. And you want to start off by adding a couple comments, and I have this on line 1 to 3. Then I've added a few variables to measure the duration, the distance, and I'm defining which pins the trigger signal are on and the echo pin. The trigger pin initiates the measurement, and the echo pin measures the distance from the sensor to the target in a certain amount of time. We'll look at that in the program. So the trigger pin is going to be an output signal from the Arduino connected to the trigger input on the sensor. The echo is an input signal on the Arduino. Here we're just telling the Arduino we will be using serial monitor, and it's going to be at 9600 bits per second. Then we come along and we will use the float distance in centimeters. So we're actually going to call up a function that's created a little bit further down. And that function is going to measure the distance in centimeters. Here we're putting a tab character, and then we're doing a serial print line to print that information. Here we have the ultrasound sensor connected to an Arduino board. And we're measuring a distance currently of 20 centimeters. So the target is 20 centimeters away from the sensor. If we look at the screen, you'll see that the distance in centimeters being measured is about 20.4, just as you would expect. So I'm going to move the target a little bit further, in this case 30 centimeters. And if we go to the monitor, you'll see that it is showing 30 centimeters. So it's measuring what we expected. Here we are testing out the servo motor, and we've got it connected to the picoscope to look at some of the signals. So what I've added down at the bottom for measurements are cycle time and high pulse width. And you'll find that under measurements, and it'll be under the time measurements. So I'm looking at cycle time, which is here. And the other one that we want to look at is high pulse width, which is this selection here. Now, once we have those two on the screen, you can take away the trigger screen or the measurement screen. You'll notice the trigger is set up for auto triggering. That's the most common one to use. I'm on channel A, which is the blue channel, and we're pre-triggered at 20%. What that pre-trigger means is that each of these divisions represents 10% of the screen. So this is 10, 20, 30, and so on. So we're triggered at 20%, which is this vertical line, and the yellow diamond is our trigger point. And our trigger threshold level is 2 volts, and the direction is rising edge. So those are all important things to notice. The other thing to notice is that our scope is set to 5 milliseconds per division. And you see that down here. This is 0, 5, 10, and so on. And we're about ready to change the settings. But before I do, down at the bottom here, it shows the current settings from our Arduino program. That's 90 degrees. Stays there for a few seconds. That's 0 degrees. That's fully clockwise. 180 degrees is fully counterclockwise, and we're back to 90 degrees. If I want to zoom in a little bit on that pulse, what I can do is change the time base to 1 millisecond per division. And there's the trigger. A little bit better resolution on the time. So when we're at 0 degrees, that's about 550 microseconds. 180 is 2.4 milli, and 90 is about 1.5 milliseconds. You have to make sure when you attach your ultrasound sensor to the servo motor that it's pointing at 90 degrees, and that's going to be forward position that we want to have the ultrasound sensor connected to.